First test of a different filming location which is more suited to bigger things, like say for instance this water heating tank. So what we have here is we have a thermostat that lets you set the temperature of the water. We have a digital display for the temperature, which is a superfluous gimmick. And then we've got a water inlet and a water outlet. And this tank is an eBay special and it's designed to operate at full mains water pressure. I think my local pressure would be close to the limit of what it can operate at. Interestingly, whereas the local, what is the name of that brand? They sell, God, I'm going to have to think about that one moment. And the answer is Ariston water heater, a very common brand here. But the Ariston one comes specifically with a little galvanic separator for the pipework, because this is supposedly a stainless steel tank in here, supposedly 10 litre too, which I want to actually test capacity. But you have a water inlet. Oh, look at this. If I unscrew this, they have a water inlet and an outlet. This one's got a little blue ring on the red circle, and this one's got a red circle on the blue. That's a bit confusing, but this is supposedly the cold water inlet and feeds down to the bottom and then the top. This should only actually protrude up to the top. I'll take the heat element out of this as well, and we can take a look inside it if it comes out willingly. But normally there is a galvanic separator from your copper piping to the stainless steel to avoid corrosion in the vicinity. All we're getting here is a little pressure release valve which screws on here, and if the water pressure gets too high, or if this thing is heating water and it can't push back against, say, a closed valve or something, it will vent a bit of water. And you do get a bit of hose to vent that in a suitable place. Other tanks sold here usually get used in an expansion tank. Anyway, let's demonstrate this by plugging it in. There is no water in it. So I'm going to keep it down low so it doesn't actually bring the thermostat on, because that would start getting very, very hot inside and be very destructive. Oh, do it, we want to see it. So I plug it in. The first thing that happens is we have a multiplex display. Oh, look at that. I can't shield it from the light very easily because the light is from all directions. And see the green LED, it says keep warm. If I turn it up to the heater comes on, it goes red, and then afterwards when you turn it down it goes green. And this just displays roughly the temperature of the water in the tank. See, I can't shield that at all. The lighting is so good here. Oh, the lighting is just, I can't block the lighting. Anyway, right, okay. Let's whip the cover off this. There are two screws under here. Velcro. You guys can let me know what you think of the new filming location. What type of screws are these? I think they're posi, but I'm not really sure. Hold on. I'll just jam it in forcibly and make it turn. No, it doesn't really want to turn with that. Let's try a small Phillips, might be the better option. So there are two screws, and rather annoyingly, they are mounted on the bottom of the unit, which means if you go to service this unit, and there are things that could require servicing, note that I have unplugged this, it means that to actually access it, you're going to have to try and unscrew it from the wall. I don't even recommend screwing it to the wall in the first place. And then sort of lift it up in something just to get access to these screws underneath. But once they're out, it unclips from the bottom and the side, and it reveals what's in the side. Here is the electronic module. We have a few items going down here. We've got the heat element here and polystyrene insulation. Well, let's start from the very beginning here. So here's the main incoming flex, which looks quite small, but it is only rated 1.5 kilowatts, 8 amps. So this flex is probably about 0.75, the look of it. Doesn't look that big. But the first thing it does is it does look actually earthed. I can test that flex as well. And then the live and neutral goes to this thermal cutout. It's worth mentioning. That looks like the manually reset thermal cutout. It looks like a last resort thermal cutout there. So that if you run this dry and it gets far too hot, or if the thermostat fails, then this will pop out, and then to reset it you'd actually have to press that in, and if it did it again then it'd be a problem. The output of that comes up to the thermostat here, which has a little capillary tube going into this down here, which this down here will be a little, basically it will be a little vial inserted into the heat element in the sleeve, but we also have another sleeve next to it for the thermistor that is going up to this temperature display. Other than that, all we've really got is a permanent feed to the temperature display, a neutral to the temperature display, and then the switched feed from the thermostat just so it can do its fancy 2 LED thing, which is quite frankly just a gimmick. Right, what next? I shall remove some wires from this. And then there's the thermostat with its little vial that goes in, and there's the thermistor potted into a little tube in the end. Right-o, okay, well, tell you what then. We'll tell you what, I'll pause while I remove some things because they may not come off too easily. They're coming off relatively easily, actually. Maybe I'm just talking crap. Okay, let's get the screwdriver into here. This is also a good reference, should you take yours apart. And we've got another wire to come off. It's the other heat element wire. The silicone smeared around the end of the heat element is a bit suspicious. What's that about? Put that down over there. We can reverse engineer everything, including the thermostat thing. Now I've got a couple of these connections. Oh, I've just put my finger right through the polystyrene. We'll get the earth wire off as well. Checks that I'm still in shot. Goodness knows if it's in focus. Goodness knows what the colour's like. For some reason it just showed a different colour temperature. And then this polystyrene cover lifts off, revealing the drum inside. Interesting. Right. Okay. How does this cylinder come out? There are a couple of screws up at the back holding that cylinder in. Let's whip him out. I did get this to take apart. I'm not going to use it. One of my biggest concerns about these mains pressure water tanks is that if they burst, they'll just spray continuous mains pressure water all over the place and they'll flood your building. So it's worth knowing that there are risks associated with that. Let me just find a place to put that screw and make sure this doesn't drop with a loud bang. Okay, that's it removed from the back. This should just come out. Oh, it's these things here. Right, tell you what, I need to remove the little rubber bungs. I'll just tilt it up so you can see me removing them. And these little sleeves. This was about £45. There are also, and it's what I use personally, vented water heaters. And you can use this as a vented water heater. What that means is that it only gets water into it when you turn a tap and it displaces the water up from it. So here's the water tank. It looks quite neat. Does that look like it's going to hold 10 litres? Doesn't really look like a 10-litre tank, does it? But I can test that. Right, I can fill it with water and then see how the weight changes, because 10 litres will be 10 kilograms. Maybe just 10 litres is an arbitrary value. There's little spot welded things in there. What's that about? Have they got other brackets inside? Oh, it might be for the pipes inside. Right. Okay, I'm going to take these nuts off to release the heat element. I'll pause while I do that because I'm going to have to find a spanner. 1 moment, please. Okay, I have found a suitable tool for removing these. It's not immediately intuitive how these come off though, because they seem to be just spinning. Is there maybe a rotating lock inside that I don't know about? Maybe I have to lift them all up fairly evenly to grip it? Or maybe it's just some mysterious special manufacturing technique they have. Is this just going to drop inside? No. Oh, it might be. Oh, I don't know. Got to make a mess of this, haven't I? Yes, that's fine. I don't have a problem with that. So yeah, although these are under pressure, you can use this as a what's the best way to describe it? A non-pressurized. much safer system just by having, say, a valve that will feed water down through the cold feed, if it's correctly marked, and back up to an open tap. But you can't have the closed tap. But that means because it's not running at mains pressure, and because there's only water going down to it when it's needed and displacing the water up, it means that it's not going to do anything nasty if it did burst in some way. A vented system. But a proper vented tap is really expensive. Oh, this is interesting. Oh yeah, we get removable nuts here. Oh, maybe can I just rotate this apparently? Yeah, apparently I can just rotate it. It bayonet caps in. Okay, what's the heating element going to like? Here's a heating element. Oh, look, it's still warm from when I powered it there. It's actually, you can see this tube down here. Instead of crimping the two ends off, it's just one tube that has both the thermal devices stuffed down it. So what about the inside? What am I seeing here? This one with the red, which is wrongly marked, does go down to the bottom now. Am I going to be able to show you this? Am I going to be able to show you this? Let me pause while I try and show you this. The spot welds in the back, they must just be temporary spot welds for something. They're not actually used inside. These pipes are just... One basically ends at that height, and the other goes right down to the bottom to displace the water up, with little holes all around it. Okay, tell you what, I'll try and show you this. 1 moment, please. Right, this is going to be ugly, owing to the fact we're looking through a little port with a pulse with modulated light. See the tube come in there? That's the cold tube, and it goes down and then to the bottom of the tank like that, where it's kind of perforated. And then the hot outlet, which is displacing the hot water up the way, is just a little short tube, just a little stub of tube there. Okay, right, tell you what, how far can I go here? Let me just focus into a better position here. Ah, that's better. Right, tell you what, I'll test this for capacity, see if it holds the full amount of water. That's quite an interesting mechanism there. Oh, incidentally, as with all my videos, I'm probably making a dog's dinner of trying to get the information across that I want to get across. So if in doubt, go into the description down below and I'll fill all the details there. But what we have here is stuff we can take back to the bench and explore at the bench. So I shall do the water test in this, and then we'll take the thermostat thing apart here, and we'll see what's inside it. 1 moment, please. Back at the usual bench, and things I've discovered since. Well, looking at the top of the tank, I thought, oh, those tubes, the dip tube that goes in is about the same size as this pipe, and I just shoved it in randomly. And when I pulled it out, it stuck and then pulled the whole tube out the thing. So these little red and blue inserts are swappable. They're quite hard to get out because they are friction fit, but you can make a little hook that goes in and then you can just donk them out. But these are the two dip tubes, and note that they're closed at the ends. This is the one that feeds the cold water down to the bottom of the tank, and it's closed at the end with holes punched all around it here so that it basically diffuses the water into the tank without causing too much turbulence, because you're trying not to disturb it too much, because it works by displacing the hot water out the top while putting cold water in the bottom. And here's where the hot water goes out the top. It has the small number of holes that the water can just go in from the top of the tank and then out through the hot orifice to your tap. Right, let's move these out of the way. This is the relief valve that screws in the top of that. There is a one-way valve in here, which may be to prevent backflow. But either way, it's a bit of an issue because it kind of traps the water, traps pressure in. Although with that water tank, when the water gets to the top, it will leave a small air pocket. In reality, the water can expand quite a lot as it heats. And so this wee vent valve may end up venting quite regularly. Anyway, let me just, before I take apart the well, it's not the thermostat, it's the temperature display module, let me give you a quick recap of how these things are supposed to work. So I shall zoom down a bit, like that, and here's the idea. Here is your undersink water heater, and it's got that, let's just keep it as a square. It's got the water inlet with its little pressure release valve that goes in the top and can squirt water out the side if it gets over pressure. But it's got the dip tube that goes down to the bottom, and it's got the shorter dip tube just at the top here. and probably a little pocket of air at the top and the heat element in it. Let's just draw a heat element in like that. And the idea is that the main water supply comes in here at full mains pressure. That's a bit of an issue with. And this goes up to your tap, your faucet. Let's just draw a very crude tap with the shut-off tap on top, the valve. And when you open this tap, it allows water to flow through the whole system, and it displaces the hot water at the top out through your tap. The difference between this and the vented system, which I much prefer, is with the vented system, you've got the same system of the dip tube and the little pick-off tube at the top and the heat element inside. But this time, the tap at the top is quite complex. If you turn the cold side of it, it always has a cold water feed to it. If you turn the cold side, it comes straight out the tap. If you turn the hot side, it diverts it down through this tube here and displaces the water up through the tap. And the downside of that is, well, there's upsides and downsides. The downside is that this is always a route that's open to the tap. And as this heats up, the tap will often drip. That's normal. Don't try and force the tap off. If it's a vented system, the tap will drip. It's fine. It's just the water expanding in the tank. And once it stops heating, it will stop dripping and the water will pull back in a little bit. But the other advantage of this is that it only gets water in when you need the water, which means if something happens, and this is not under pressure, this tank, that one is, up to £100 a square inch theoretically on mains water supplies, or more potentially. And this one is not under pressure, which means they often just use a plastic container, and if it was to worst case scenario, burst, whereas this one will just spray water out continually because it's got a direct cold water feed. This one is only topped up with water when you turn the tap. So any water that's in it could potentially leak out, but that will be it. It won't flood your place out. This is important if you live in the top floor of a building. Right, let's take a look at the digital thermostat thing. This is a fairly standard thermostat. This is the circuit board that gives you a little fancy display, and it's got 3 wires going down to it, live, neutral and the switched from the thermostat, but that's just purely for drama. It's only for show. It's so it can light its little standby heating or active heating. It's a gimmick. You don't even need this. The best way to set these things is to set the temperature. Initially, if you get one of these, I recommend setting it quite high just to basically sterilize it, and then set it to a temperature that's just nice to run your hands under, because that's what these things are best for, hand washing. They can't be used to wash tons of dishes or fill buckets of water, but they can be used to rinse cups and wash your hands. That's the main advantage of these things. Now, screwdriver. Let's whip these screws out that hold in this completely frivolous temperature display. Interesting, they've used white LEDs for it. I mean, it's a nice enough display. The white LEDs will fail, probably. They'll fade. You'll get segment fatigue after a while, as happens with these. But nobody cares, because the hot water will still work as long as the old bimetallic thermostat is working. Right, let's get this out of the way. Sadly, this has a sticky pad in the back. Again, it's for insulation probably. Oh, it's coming off all right though. Ah, there is the microcontroller. There is a bridge rectifier. This capacitor is probably a capacitive dropper with an inrush limiting resistor. Right, tell you what, I shall reverse engineer this and we can take a closer look. One moment, please. Okay, let's explore. Nice enough displays, I have to say. Those rather bold digits, but the decimal points don't even have LEDs in them. They are a cost-optimized display. What we have on the circuit board is a dropper capacitor and a resistor going to a little power supply based on a bridge rectifier, a Zener diode, a capacitor and a discharge resistor. That's presumably to make sure that when the power gets turned off for some reason, it discharges quite quickly and ensures a nice proper reset the processor, because otherwise with very low current draw you can actually have a situation where the voltage goes down so slowly that it doesn't do a proper reset if it gets turned off and on again quickly. The other thing that's on the main side is this thermostat input, which goes to an opto-isolator, and then between it and neutral are a diode, 2 resistors, and then the LED and opto-isolator that then signals over to the other side. We have the thermistor, which is an unusual value. It's 60K at ambient room temperature. And it has a balancing, it forms part of a divider with a 47K resistor over here with a bit of smoothing. And then after that, the 7-segment display has the 7 segments, but it's multiplex with 2 common negatives, common cathode. And the LED displays have their own 510 ohm resistor. I didn't put that value in. But there's also instead of a decimal point, they've put these 2 LEDs, the red and the green LED, that's these 2 LEDs, and they've got their own resistor each off the same multiplexing. So let's take a look at the schematic. Oh, incidentally, I did test the 10-litre capacitor, the 10-litre capacity container for actual capacity. It's 6 litres. They've cheated. Not to worry. This is quite frankly what we expect, and if you contested it, they'd say, oh, it's 10 litres if you let it warm up the new water for a while. Incidentally, that's how this system works. It's not like the instantaneous ones that draw tons of power, like 8 kilowatts. This unit is only 1.5 kilowatts because it relies on storing that little 6-litre tank of water, heating it up as a reserve of water, and then it's available on demand. But when you run it too long, it will suddenly start going cold, but leave it for a while and it will heat back up again. It just means that it only draws about 6 to 8 amps. In Europe, and it would be a bit higher in America. It would be, in America, 1.5 kilowatts would be roughly 15 amps to get the same sort of heating capacity. But anyway, I digress. Here is the capacitive dropper. It's the 220 nanofarad X2 style capacitor with 2 270K resistors across it. That's quite good that it's a nice design actually, I have to say. There's a 51 ohm inrush limiting resistor, plus also it acts as a fusible resistor to the bridge rectifier. That is rectified. It provides the power supply with that Zener diode, 5.1 volt Zener diode, the discharge resistor and the smoothing capacitor, 220 microfarad. Then that powers the microcontroller with its little decoupling capacitor, and it monitors the opto-isolator via this opto transistor from the opto-isolator, forming a potential divider with this 47K resistor. And for driving that opto-isolator over here, the LED, it just has the diode, 2 resistors, which I've not drawn the value of those in as well. How shameful. That's 100K, 100K and 100K. And these are 510 ohm. There we go. I've drawn them in now. The thermistor forms a potential divider with a 47K resistor. It has a little filtering capacitor across it. Oh, and I've left a resistor off there as well. Wow, Mr. Amateur. It's 1K. They've just basically, because it's going to external circuitry, they've got a little resistor in there to limit static spikes, transient spikes. It's because it's external, it just adds a bit of extra protection for the microcontroller and a bit of filtering. And then that goes in. And there's the 7-segment display and the output, which could have been used for the decimal point, but has instead been used for these 2 LEDs. This is multiplied by 2, 1 per digit, and then there's a resistor per digit, and then a resistor per LED. So there's effectively 4 of those resistors. And that is it. So, what's my general thought in this unit? Well, if it wasn't somewhere that could flood all the tenement flats down below, or apartments down below, or even just one room down below, if you stuck it in a bathroom upstairs, for instance, and it burst, it would flood your house out and damage the ceiling. Not great. In that sense, you'd be better getting a proper one, or my preference, the vented ones, even though it does complicate taps and things a little bit. However, for a workshop use, for just a convenient source of water, it's earthed. It looks okay. I didn't test the cable. I didn't test the flex. Let me just do that right now. Okay, I just chopped the plug off it because, well, what the heck? I got this to explore in the first place. It is a properly compliant plug, the look of it. Earth's connected. Neutral's connected. Live. is connected. Is the fuse going to disconnect the live? Is the fuse real? The fuse is actually, it's rated 5 amps. Okay, that's reasonable enough. Because it is supposedly 1.5 kilowatts, which would be 6 amps. They've probably just used this because it is 0.75 millimeter flex. But anyway, let's test and see if the live is now connected. No, it's not. So it is going through the fuse. Let's crush the fuse and see if it's a proper fuse with sand in it. Yes, some sand came out. So yeah, that's all right. Okay. Ow. Just stabbed myself with some of that, but that's all right. Let's test for it being copper. Now, the first easiest test is to see if it twists well. Let's strip it and just twist it. It kind of twists. Hold on. Not totally convinced yet. Oh, you know what? I have a horrible feeling that's copper-coated aluminium again. It is melting and blobbing back. It just... not sure about this. Give me a moment. I'm just going to do another test. Test and comparison done. I do think it is copper. A bit of balling up, but it's not doing that flopping down thing the other stuff does. But it feels strange. I did scrape it and it looks coppery. You can never tell what they're doing these days. You just don't know if they're coming up with some new cost-optimised copper alloy. But I think it is copper. Quite odd that they've got such a low rating of fuse because they've skimped on the cable size. But having said that, ultimately, you've seen how I opened that up, those 2 screws. If you get one of these for your own use, it's up to you if you want to make it safer. Although having said that, it doesn't run for huge lengths of time. And they are just the general trend is to go away from using properly sized copper cables because of the cost of copper these days. But there we have it. It's an interesting thing. As I say, not suitable for use on top floors of flats where flooding would be an issue, but maybe in a workshop it may have its place. Otherwise, buy, for not too much more, an Ariston unit, which is in the UK, or they'll have different ones in America, which are similar but just engineered a little bit better and carry a guarantee with them.